Hey guys, unfortunately I may not be able to be in 8th period tomorrow, but I wanted to make sure that I was able to go over some of the big ideas with you that you'll need to be aware of as far as neurons. A couple of things I want you to be aware is of all the upcoming assignments. You guys are kind of lucky the way this week falls. I will see you on Wednesday. But your next work isn't due until Friday. It's actually during class time, so I need to see your neurotransmission practice by class time on Friday, and also you need to make sure you read pages 67 to 68 in the attached brain scans document. Then you have some other stuff due next week, but these are super important that you complete by class time so we can go over them. Cool. So as far as I want to make sure that you guys kind of have some exposure to, and you'll have that exposure in the Edpuzzle that you're watching tonight, and you'll also have exposure to that through the reading assignment that you did. I definitely want to make sure you understand the structure of neurons and how those neurons communicate with one another. Skip through this here. If you have a chance, there's this clip from America's Got Talent that's pretty funny, dealing with phrenology. Phrenology, I believe it mentions in the front of the book, that's how people used to study personality traits by like squeezing different parts of your head. Apparently that meant different things via divots or bumps and things. So it's just a funny clip to look at. So it's really important with this unit, with 3A of Chapter 3, the first part A, is the neuron. It's essential that you understand kind of the function of the neuron and the structure of the neuron, really what it does. We have billions of neurons running all throughout our body. First, we have the sensory neurons, and they're also called afferent neurons. So I know you can't see my hands. I do a lot of hand motions with this, but the afferent neurons, sensory neurons, what they do is they take information from our senses, from either our fingertips or our vision, our hearing, whatever, and it takes that information, then it sends it to the brain. And we have millions of sensory neurons. Again, they're also called afferent neurons. So if you're hit by a couch, right, if you get crushed under a couch, you're going to feel that because of your sensory neurons. If I were to touch a hot stove, my sensory neurons would send information to my brain that says, this is hot, take your hand off. Your motor neurons then are also called efferent neurons. So remember, your sensory neurons called afferent neurons. Your motor neurons are called efferent neurons. The way I remember this is because efferent starts with an E and so does exit. And so motor neurons take the information out. So like if I was to touch a hot stove, my sensory neurons would tell me, you're touching a hot stove. And then my motor neurons would communicate like, hey, pick your hand up off that hot stove, right? So we also have millions of these efferent neurons. So afferent in, efferent out, afferent in, efferent out. Then we have interneurons, of which we have billions, believe it or not, and they take a message from our sensory neurons to other parts of the brain or to our motor neurons. Okay, so afferent neurons are sensory neurons, efferent neurons are motor neurons, and the interneurons, I like to think of like the little messengers all throughout our body. So what's super crucial is that you understand the structure of the neuron, okay? If you kind of talk through from the beginning to the end, you'll understand the process of the neural structure. Arguably the most important part of the neuron is the cell body. Again, remember, we have billions of these in our body. Some of them are super long, some of them are super tiny. It just depends on where they are. So the cell body, another way to refer to that is considered the soma. It's another word for that. So S-O-M-A. That is the cell body. And then obviously in the cell body, we have the cell nucleus. These branchy things, and I know you can't see this, I always stretch my hands up in the air because I'm like, the dendrites like reach out to get incoming signals from the previous neuron. Then the electrical impulse that occurs because the dendrites receive neurotransmitters, it then turns that into electrical energy, and it moves the signal through the cell body and then through what I like to call the tubey thingy, which is actually known as the axon. And the axon just makes sure that that electrical message is sent from the receiving dendrite to the terminal branches, to the end of the neuron. The action potential, or that neural impulse, only goes in one direction, from the dendrites at the top of the neuron to the terminal buttons at the end. Now, what we have covering the axon is called myelin sheath. And so myelin sheath is much like the insulation, that pink stuff that looks like cotton candy in your house, right? And insulation in our house, it keeps the heat in. So what the myelin does is it actually keeps that electrical impulse in. It keeps things insulated. So that way the neural impulse moves more quickly through the neuron. Now, people suffering from MS, for example, they have a breakdown of the myelin, so that signal is not able to pass through as quickly and keep that electrical signal in. Okay, so once you pass through the axon, once that electrical charge passes through the axon, it's going to reach the terminal branches of the axon. Now, these terminal branches, I think of terminal like terminal illness or like terminus in The Walking Dead, like end of the line. They have right here at the end vesicle sacs, and inside those vesicle sacs are the chemical messengers that are called neurotransmitters. Those neurotransmitters, once they get the signal that, okay, we get this electric impulse, they're going to be released across the synapse. When I see you again on Friday, we'll work on like drawing the neuron. I think it's really important as we draw it to kind of talk through that process. So hopefully that'll be more helpful for you as well. The neurons do not touch each other. There's a space called the synaptic gap or the synapse right between your two neurons, okay? And they're super microscopic. So how a neuron fires, so as I mentioned, it is an electrochemical process. So it's electrical inside of the neuron, and then it is chemical in the actual neurotransmitters in the synapse, okay? And the actual firing is called an action potential. It's that electrical signal, and again, it can only go from the dendrites to the terminal branches. It doesn't go any other way. It can't go backwards or something. There is a video clip also available in this PowerPoint slide or the slide presentation that you link you to a helpful video. Something you want to be aware of with neurons is that there's something called the all or none response. Just like a gun, like you either shoot it or you don't. It's not like if you squeeze it lightly, it'll just shoot out a little, right? Or a toilet, you can't just like flush it a little. You either flush it or you don't, right? So either the neuron fires or it doesn't fire. So sets the action potential. As I said, the dendrites receive the neurotransmitters, those chemical messengers from another neuron that has crossed, my cats are fighting, that has come across the synapse and is being received by those receptor sites of the dendrite. There's something called a threshold. So basically, like let's say the receptor sites in the dendrites will take 5 neurotransmitters, and I'm just making up that number, but it's going to take 1 neurotransmitter, 2 neurotransmitters, 3 neurotransmitters, 4 neurotransmitters. Once it hits its fifth neurotransmitter, or like it's reached its threshold, it's basically like close the door on and it's not going to let any more neurotransmitters come in, and that's what's going to start that electrical process that's happening through the neuron. So this is the complicated part. I'm going to show you pictures that's in your book and also available in this presentation that hopefully make this a little bit easier. But basically what happens is once that electrical process happens is it opens like little doors or portals. I think of them as like little doors with handles in your axon. And so as soon as that electrical impulse comes in, it's going to let in positive ions that are outside of the axon. It's going to let them in to the axon, right? And then it's going to mix the negative potassium ions that are already inside the axon, and that's what's going to start the process. And then it's going to open the next portal door on the axon, the next portal door, and that process is going to happen all throughout the millions of neurons that we have throughout our body. Okay, so steps of the action potential, kind of just mentioned that. Great, cool. This is the image that kind of shows what's happening with depolarization and happening kind of as a zoom in the axon as the action potential is occurring. So there's something called the refractory period. You can kind of think about this like your cell phone. Like if you use your cell phone and the battery is dead, like you can't use it anymore. You have to charge it, plug it in and charge it. The same thing happens with neurons. Once they fire, once they have their action potential go through, they need like a resting period to a refractory period to like recharge their batteries, right? To kind of get back to its resting state. So the refractory period occurs and then it's like ready again. So if you think of a toilet, you flush it, right? And the refractory period is when it's filling the tank back up with water. And then once it reaches its resting potential, it's ready to flush again. I'll read that right now. So what I would like you to do today, I'm hoping I'm there, but if not, I would like you to complete the neural impulses are like a assignment, and I will make this an assignment in just a moment on Schoology. But in case, I will definitely make this assignment, but in case you want to access it another way, I can show you that. actually, I need to stop here. I will assign this in Schoology. You'll see the assignment. This neural impulses are like A, because my free recording limit is about to be reached. Thanks, guys, so much. Please let me know if you have any questions or anything.